All right, so here we're going to be talking about making predictions using both a graph and an equation. We're looking at our phone charging example still, and the first question says, using the graph, predict the battery level if the phone is plugged in for 25 minutes. Now you'll notice whenever we have a prediction, I'm going to give you something and you have to find the other. In this case, I give you a time of 25 minutes. You have to find the battery level. So what we're going to do here is take a look at 25 minutes. Minutes is on the time, so you're going to go to the x-axis or the horizontal axis for time. You're going to find 25, and you're going to draw a line from 25 all the way up till it hits your best fit line. So you see that. We hit our best fit line. The next thing you need to do is go over so that we can predict the battery level. So you're going to draw a line now going across to figure out what that battery level is. When we go across, we notice we hit the number 35, and this is a battery level, so this would be 35%. Likewise, it says using the graph, predict the time it would take to have a 45% charge. This time they give us 45%. Well, this is a battery level, so we are going to be starting on the vertical axis, and we want to find 45%. We're going to draw a line from 45% all the way to our best fit line. So you'll notice once we hit our best fit line, we'll then go down to figure out the time. Drawing that line down, we see it's somewhere between 30 and 35. I happen to predict 33. And notice our units of time, our time axis says our unit is minutes, so we would say 33 minutes. Now we can also make predictions using our equation. This equation is the one that we built earlier. So it says, using the equation, predict the battery level of the phone after 60 minutes. So you'll notice that I'm giving you 60 minutes. It says, show the equation first, then complete the substitution. So what we're going to do is start with our equation. B is equal to 1.2% per minute, or percent over minutes. Sorry, my pen is not the best. Times time plus 5%. Okay, now let me fix that percent up there. It's going to drive me nuts. Okay, so percent over minutes. All right, now we're given 60 minutes. We need to plug this into our equation. Now we can only plug things in for B or for T. These are our variables. Everything else in here is a unit. We can't plug things into percents or minutes. So we have to pick, where would 60 minutes go? Is that a time or is that a battery level? Well, that's a time, so we're going to plug it in for T. So we're going to rewrite it, but fill in 60 minutes for our time. So everything else stays the same, but for time, we're going to put 60 minutes in. All right, so let's see. Now, you'll notice that this 1.2% per minute and the 60 minutes, these are next to each other. That means these are being multiplied, and then we need to add 5%. You'll notice the B, which we're trying to find, battery level, is already by itself on the left-hand side of our equation. So all we need to do is math this out. We'll do B equals, and we'll multiply this 1.2 times 60. All right, so we'll do 1.2 times 60, and I get 72. You'll notice minutes is on the bottom and the top, so it's canceled, and we're left with percent. But you can't forget this 5% as well, so we'll say 72% plus 5%, and 72 plus 5 is equal to 77%. So our battery level here is 77%. And after an hour, that means that my phone has 77% charge. Now I'm going to erase this and we're going to do the next one together. All right. The next one says, using the equation, predict when the phone will be fully charged or 100% battery. Show the equation first, then complete the substitution. So I have my equation first. I kind of cheated. I left it there. But you'll notice I'm given 100%. 100% can be plugged into either one of our variables, B or T. We just have to figure out which one it belongs to. Well, 100% is a battery level, so 100% is going to be plugged into B. So when we rewrite our equation, we're going to rewrite it, but instead of B, I'm going to fill in 100%. So 100% is equal to 1.2% over minutes times T plus 5%. And remember, this 1.2% per minute and time are being multiplied. Now, this time it's going to be a little bit more algebra heavy because if you notice, I'm trying to get T by itself, and T is in the middle of this mess. Okay. Now, you probably remember PEMDAS, right? Now, if I want to get T by itself, I have to do the opposite of PEMDAS. You know, the S in PEMDAS stands for subtraction. You'll notice this adding and subtractions last in PEMDAS, but it's going to be the first when we're trying to get T by itself. So what we're going to do is I'm going to get rid of this adding 5%. In order to get rid of adding 5%, I'm going to subtract 5%. So minus 5%. And what I do to one side, I have to do to the other. So I'm going to subtract 5% on both sides. I'm going to draw a big long bar here. That means my equal sign. This adding 5% and subtracting 5% cancel out. And now I can kind of redo my math. 100% minus 5% is 95%. I am going to drop down my equal sign. And I still have this 1.2% per minute. And I still have my times T. All right, so still need to get T by itself. You'll notice because that 1.2% per minute on time are next to each other, I can undo that multiplication by dividing. So I'm going to divide both sides by 1.2% over minutes. Okay, so I'm going to divide on this side as well, 1.2% over minutes. All right, well, this cancels out, and I have 95 divided by 1.2. So I'm just going to kind of carry this over here. 95 divided by 1.2 is 79, and this is what T is equal to. So I'm going to say T is equal to 79. And if you plug it in your calculator, you'll also see that you get 1.66666. We're going to round to 2 decimal places. That's 1.7. Okay, and if you look at units here, percent and percent would cancel, and I have 1 over minutes. So that's just minutes. And that makes sense. Time we have been measuring in minutes. So if I wanted to get my phone to be fully charged, I would see that time is equal to 79.17 minutes, which is roughly an hour and 19 minutes. All right, let me go ahead and erase this. And then I'll give you the steps to do on the next one. All right. Thank you for your patience. All right. So the last thing you're going to do, it says below is a graph representing the price of pizza when various toppings are added. Now, take a look here. It says answer the questions on loose leaf. Refer back to the previous video if you need help, meaning this video here. What you're going to do is you're given the equation and the graph. The equation is P equals 0.5T plus 499. You are going to use the graph to figure out the cost of pizza when 4 toppings are added. Also using the graph, you're going to predict if the pizza costs $6, how many toppings does it have? For 1 and 2, you don't really need to show your work. Just make sure you give me a number with units. 3 and 4, though, you're going to have to use the equation, and you're going to have to show all your work in units, just like we did in this video. Once you have that, you are going to Well, you have to take a picture of your work. You can either attach it to this slide or attach it to the assignment thread. Very important, the last thing you do is go to the last slide. You are going to download graphical analysis. You'll notice all those pretty graphs that I had in this slideshow. Those graphs were created from graphical analysis. We are going to do a lab, and you are going to need to have graphical analysis in order to complete this lab. So follow the directions in this slide, and then you'll be good to go.